Hello students, this is Miss Edwards. Today we're going to start Unit 1 for Common Core Algebra. Lesson 1 has to do with evaluating expressions. First thing I need you to do is write down some vocabulary. The first word I need you to know and be able to define is variable. I know you've heard that word before. It is simply a letter that represents a missing number. The second word you need to know is expression. That's what we're going to be evaluating today, is expressions. That is a group of numbers, variables, and operators. By operators, I mean plus signs, minus signs, multiplication, or division. A simple example would be something like 5x plus 7. It's not set equal to anything. It's one half of an equation, either the left side or the right side. This one has a couple of numbers. It has a variable, and it also has an operator. And lastly, you need to know what it means to evaluate. A lot of times on the Regents exam, instead of using the word evaluate, they may say simplify. When you evaluate an expression, you are finding the value of an expression. And by finding the value, I mean numerically. Finding the numeric value of an expression. So hopefully if you guys are falling a little bit behind, if I'm moving too fast, the beauty of this is you can pause it, you can rewind it until you get those vocabulary words down. I'm going to start you off easy. This first expression says 4x minus 7. That means 4 times x minus 7. And they want you to evaluate the expression for when x equals 5. So you're going to simply rewrite the expression, replacing wherever you see an x with 5. If you remember the video we saw at the end of class today, order of operations, PEMDAS, parentheses exponents, then multiply and divide from left to right, then add and subtract. Multiplying comes before subtracting. 4 times 5 is 20. Subtracting 7 from that, you get a final value of 13. Sometimes you'll see some exponents in the expression. Don't be afraid of exponents. X is still equal to 5. So we're going to take 5 and we're going to square it. We're going to subtract 4 times 5 and then take away 2. Exponents first. 5 squared is the same as 5 times 5. So 5 squared is 25. Negative 4 times positive 5 is negative 20. Take away 2. Now that you're down to just subtraction, you work from left to right. 25 minus 20 gives you 5, and 5 take away 2 gives you a final value of 3. Now, when you come into class tomorrow and you've shown me that you have these notes completed, you'll get right to work on some examples. Some expressions are a bit more complex than others. Let's take a look at some of those. Here we want to evaluate when x equals negative 2. So again, wherever we see an x, we're going to replace it with negative 2. So we get 2 times negative 2 plus 8. We're going to square that. We're going to divide that entire numerator by 3, and then we have a plus 1 hanging off the end. Well, parentheses first, negative 2 plus 8 is the same as 8 minus 2. So in parentheses you now have 6 squared, all divided by 3 plus 1. Well, 6 squared is 36. So we end up with 2 times 36 divided by 3 plus 1. 2 times 36 happens to be 72. So 72 divided by 3 plus 1. 72 divided by 3 is 24. 24 plus 1 is 25. So there's your final value. It went from being a big mess to one numerical answer. Now this is a square root symbol. You may think that there's no exponents in this expression, but guess what? There is. A square root symbol is an exponent. When you take the square root of a number, it's the same as raising that number to a 1/2 power. So we're going to go ahead and replace that x underneath the square root with what x is equal to, negative 2. So negative 3 times the square root of negative 2 plus 2. We're going to divide that whole numerator by 8 and then subtract 9. Negative 2 plus 2 is 0. So now you have negative 3 times the square root of 0, all divided by 8, minus 9. Now it gets simple, because the square root of 0 is 0, so you end up with negative 3 times 0, divided by 8, minus 9. Well, negative 3 times 0 is 0, and 0 divided by any number is 0. So this whole entire fraction has a value of 0. Take 9 away from that, you end up with negative 9 as your final answer. Now what I'd like you to do now is there's just a couple important points I want to make. You can do this on the back of your notes, because I know the back of your notes happens to be blank. So on the back of your paper, if you could following notes. We saw that 5 squared was equal to 25. But what is negative 5 squared equal to? A lot of students will say, well, Miss Edwards, it's equal to negative 25. But it isn't. Remember, when you square a negative, negative 5 squared is the same as negative 5 times itself, negative 5. And you got to remember that a negative times a negative is a positive. You get positive 25 here as well. So be careful when you're squaring a negative, you don't get a negative, you do get a positive. The other common mistake that kids make is when you have an expression, let's say like 2 times 3 squared. A lot of students will do 2 times 3 first and get 6, and then square that and get 36. And that's not correct, because again, if you think of the order of operations, exponents comes before multiply. Exponents and then multiply. So you have to take care of this exponent first instead of doing 2 times 3 first. You end up with 2 times 3 squared, which is 9. You have a final value of 18. So just a couple points that I wanted to make, because these are very common mistakes made by students. When you come into class tomorrow, if you could show me the front and the back of your notes so I can see that you've completed it. And I hope you had a really great first couple of days. I know that I did. It was a pleasure meeting you guys. And just so you know, at the end of class tomorrow, you'll be having a quiz on evaluating expressions. So come into class tomorrow ready to practice. I will see you then.